In Module 4, Lesson 16, we'll be working on true and false number sentences. Okay, in the opening exercise, we're going to determine what each symbol stands for and provide an example. The very first symbol in our table is such an easy one, an equal sign. The equal sign stands for when two values are equal or have the same value. Okay, for example, the fraction 1/4 has a decimal equivalent. If you take out your calculator and do 1 divided by 4, its decimal equivalent is 0.25. These two values are equal. They have the same value. Equal signs are always used with equations. A statement that the values of two mathematical expressions are equal, indicated by the equal sign. Okay? These two symbols you've probably seen before. This one is greater than. It means that one value is greater than the other. Okay? For example, negative 4.2 is greater than negative 7. Okay? Negative 4.2 is closer to 0 than negative 7. I always tell my kids, oh, pretend you owe somebody $4.20. If you added a 0 here, you'd be down $4.20 or down $7. Okay, you'd rather be down $4.20. You never want to owe people money, so that one would be greater. The mouth of the sign is always going to be open to the larger number. Some people say it's like a Pac-Man. I've seen some people say it's an alligator. Okay, but it's like eating the greater number. This is the less than symbol. I always remember that this is less than because it looks very similar to an L. Okay, so this symbol is less than. I'm going to stick with our rational numbers because it's cool to practice ordering negatives in integers. It's very tricky sometimes. Negative 5 is less than the value negative 1. Okay, negative 1's closer to 0, so that would be actually greater than negative 5. Okay, these two are probably new. They're actually a combination of these two and this first symbol. Okay, this makes an L, so I know it's less than, and it also has a bar. This means less than or equal to. It can be one or the other. Okay, so I could make a statement, a true statement with that sign that said 17 is less than or equal to 17. Okay, 17 isn't less than 17, but it is equal to, so this makes this a true number sentence. Okay, this one is greater than or equal to. Either one. Okay, so for example, 18 is greater than or equal to 5. Okay, 18 is greater than 5, so that also makes it a true number sentence. These four we're going to be dealing with a lot in the next couple of lessons. They are called inequalities. An inequality is a number sentence where two values that are not equal have a relationship that's called an inequality. Okay, that means they're not equal to each other. Okay. So let's go down. I'm going to show you some of these in action. We are going to go through 6 examples together. We are going to determine if the equation, something with an equal sign, or the inequality, greater than, less than, greater than or equal to, or less than or equal to, results in a true number sentence or a false number sentence. Okay, so I'm going to go through first. I'm going to do this one first. This has an equal sign, so it's an equation. Okay, x plus 15 is 63. So now I'm going to replace my variable with the number 48. 48 plus 15, and I'm going to see if it's 63. And it is. Okay, this is what we would consider a true number sentence. Okay, let's go to the second one. X minus 72 is 97. Okay, so what if x is 151? Okay, I'm going to plug that value in for x. I'm going to take 72 away, and I'm actually going to see if it's 97. 14 minus 7 is 7. Okay, this is a false equation. Okay, it does not work. And I'm going to put an E for equation here too. Okay, this is not true. The next one, I'm actually going to put a dot in between here to expand that, because some kids always forget that's 5 times x. 5 times x is it greater than 30 if x equals 6. This is an inequality. It's not saying that this side is equal to this side. It's saying they're not going to be equal. Okay, so I'm going to substitute the 6 in for the x. And it says 5 times 6 is greater than 30. 5 times 6 is 30. So is 30 greater than 30? No. This is a false inequality. Okay, let's go to the next one. This is how bad my eyes are. I can't tell if that's I think that's a division sign. Oh, and I'm wearing my glasses too, don't tell anyone. Anyway, x divided by 7 is less than or equal to 15 if x is 105. So let me plug that in. I'm going to take 105 and I'm going to divide it by 7. 7 can't go into 1. It goes into 10 once. There's 3 left over. Drop the 5. 7 goes into 35 5 times. So if I write this out, my answer of 15 is less than or equal to 15 in this inequality. This is an inequality because it has that symbol. So this is a true number sentence. Okay, great. Let's go to the, oh, I love the next one. I'm going to expand it with a dot because this is 64 times p is greater than or equal to 100 if p equals 1/2. I love when I multiply by fractions. So it's 64 times 1/2 is supposed to be greater than or equal to 100. Okay. You need to multiply fraction by fraction. So I'm going to put a 1 underneath the 64, and then I'm going to do top times top, bottom times bottom. So it's 64 over 2, or 64 divided by 2. When I divide 64 by 2, I get 32. Is 32 greater than or equal to 100 in this inequality? No. Okay, it's not. So this is a false number sentence. Okay, last example before we send you to practice on your educanon. 5 7/10 minus d equals 2 4/10 if d is 3 1/10. Okay, so I'm going to substitute that in. I'm actually going to do 5.7 minus 3.1. And this is an equation because it has an equal sign. When I subtract these two values, I get 2 6/10, not 2 4/10. So this equation is false. Okay, good luck. I wish you luck on your educanon practice. Make sure you show all of your work just like this.